So when you see an absolute value equation, I'm gonna zoom in on this one first. All right, we have to get this box by itself. So the first thing we're going to do is get rid of that plus 9. Let's subtract the 9. So that would be -3 times the absolute value of p plus 6 equals -12. Again, this is my box. I got to get rid of the -3. -3 is being multiplied by the box. So what's the opposite of multiplying? Dividing. So we're going to divide by -3. And now we finally have p plus 6 equals +4. And my second equation would be p plus 6 equals -4. So there's two equations when we solve an absolute value. One is positive, one is negative. +4, -4. So how do I solve this equation? To solve for p, I need to get rid of that plus 6. So I am subtracting 6. So p equals -2. P equals -10. And that would be your solutions. Is that second equation an absolute value equation? The one on the right? Do you see absolute value in this one? Nope. So we're just going to solve it like regular. So we're going to bring our 7a's. I'm going to subtract my 7a. So 5 equals 2a minus 12. Because 9a minus 7a is 2a. And then I'm adding the 12. $17 equals 2a. And then your last step is to divide by 2. So a equals 17 over 2. And you could also write that as a decimal. I think as a decimal it would be 8.5. So we have two more inequalities to solve, and then we're going to get into 9.3. So go ahead, take out your notes. I think we ended up yesterday on page 8. I'll check that later. Alan, is that page 8? 9, page 9. Go to page 9. All right, so for page 9, this says less than. So this is a less than, which means it's going to be between. So your first step is to get the absolute value by itself. So that minus 6 that's being subtracted from my box, I'm going to add it. So that would be x plus 5 is less than +1. When it's a less than, the graph is between. So I want you to put another less than and the -1 on the other side. How do we get rid of the +5 that's in the middle? Subtract it, but we have to subtract it 3 times. Subtract it from the left, the middle, and the right. So -1 minus 5 is -6. 1 minus 5 is -4. So your solution is between -6 and -4. So when you graph that, let me zoom in on my number line. I'm putting an open circle on -6 and an open circle on -4. It's just a little bitty graph right in the middle. All right, so again, we have an absolute value. We're going to make our box. This is another less than, and less than is between. So we're going to start by subtracting 8. And then to get rid of that 4 that's directly in front, we divide it by 4. So 6 is less than 2x. Sorry, 6 minus 2x is less than or equal to +4. And what am I going to put on the other side? When it's between, what goes on the other side? A -4. -4 goes on the other side. So we're going to solve this for x. Subtract 6. So then -10 is less than or equal to, let me go to the other side because I'm out of space. So that'll be -10 is less than or equal to -2x, which is less than or equal to -2. Divide everything by -2, which means we have to flip our inequality. So it becomes a +5 and a 1. So x is between 1 and 5. Except this time we have close points. So put a close point on 1 and a close point on 5 and connect it. So we're going to start in 9.3. We'll finish it out on Friday. Since I will be out for the next 2 days, I am going to update when our next test is going to be. That's probably going to be pushed back a day, and I'll give you that information when I come back Friday. So go to page 10 in your notes, and we're going to start talking about the 3 different linear equations. We're only going to talk about one today. So page 10, go ahead and copy down these 3. 3 different ways to write a linear equation. So the first one is slope-intercept form. The second one is standard form. And these two actually go together. So I would probably, next year, I'm going to reformat my notes so that these two are next to each other. And then point slope. So take a moment, copy down those three, and then we'll start practicing with slope intercept today. I don't know if we do slope intercept or standard form, but we'll see. All right, so slope intercept form is y equals mx plus b. That's the format we use for graphing. M is the slope and b is the y-intercept. Standard form is what we're going to talk about today. For standard form, you have all whole numbers. So it has to be all whole numbers. A has to be positive. And we're going to write it so we have the A term first, then the Y term, and it equals C. Okay, so today we're going to focus on standard form. Friday, we'll talk about slope intercept, and then next week we'll talk about point slope. So let's go ahead and get started with writing these in standard form. So again, standard form says it has to be all whole numbers. The A term has to come first, then your B term, and it has to equal C. So in other words, X and Y have to be together on the same side of your equation. So all I need to do to put equation A in standard form is move this negative 3x over. When I move it over, it becomes positive because I'm adding it. When I move it across, I'm adding it over. So I'm adding 3x. Oops, I didn't mean to write 3y. I'm adding 3x, so it would be 3x plus y equals 7. And that's standard form. So you have to ask yourself, do you have all whole numbers? Yes. Is A positive? So A, let's go ahead and write this off to the side, A, B, and C. So what is A? What's the number in front of X? 3. What's the number in front of Y? It's invisible, it's a 1. Let's go ahead and write that 1 in. And your constant is C. All right, I'm going to do these out of order. Let's look at C, because C is also pretty easy, so let's do that one. All we have to do is move this 7y over. When I move it, I subtract it. So I get 3x minus 7y equals 5. So now let's ask ourselves our question. Do we have all whole numbers? Is the first number positive? Yes. So let's write A, B, C. Go ahead and write the A, B, and C in that equation. A is always the number in front of X. B is the number in front of Y. And C is the constant that it equals. So for this one, A is 3, B is negative 7, and C is 5. All right, so now let's look at the ones that we have fractions in. Let's look at equation B. So the first thing I need to do is move this over. So I'm going to subtract it. I'm subtracting 4/5 x. So that cancels out. So I have negative 4 over 5x plus y equals negative 2. Now we have to clear out the fraction because we cannot leave a fraction in standard form. So to do that, we're multiplying everything by my denominator. And what's my denominator? What's the number in the bottom? 5. So I have to multiply everything by 5. But because this is also negative, then I need to multiply everything by a negative 5. And the reason why I'm doing that is because when I multiply these two negatives, it's going to change to a positive. So pick up your calculators and multiply all 3 by negative 5. And there's an invisible 1 right here if you want to write that 1 in. So you're taking negative 5 times negative 4/5. Cortez, there's a calculator right there on that desk. Go ahead and grab it. And let's start multiplying it out. And those yellow calculators have a fraction. Does anyone need help typing it in the calculator? So you're typing in negative 5 times negative 4/5. You should get positive 4. Who got positive 4? All right, so positive 4x. So keep going. Then you're taking negative 5 times 1 and negative 5 times 2. Okay, who got this as their answer for standard form? All right, so now let's write off to the side my A, B, and C. A is 4. B is negative 5. And C is 10. All right, last equation for standard form. So for this one, we're going to add 3/4 x. So this is going to move over. So it becomes a positive 3/4 x plus 1y equals 2. Raise your hand if you know what I have to multiply by. All right, Kaden, what would I multiply by? By 4. Multiply everything by 4. And do I have to multiply it by a positive 4 or a negative 4 for this one? This one is positive. Good job. All right, go ahead and do that. Multiply everything by 4. All right, who got 3x plus 4y equals 8? Good. So let's write our A, B, and C. A equals 3, B equals 4, and C equals 8. All right, let's look at this graph at the bottom. Ooh, I thought I had a graph at the bottom. Oh, that's it then. All right, so that's the end of today's class. And then Friday we'll pick up on slope-intercept form.